Okay, guys, let's talk about 15B materials. We're going to look at pollution control measures and then types of indoor pollution, right? We've talked about factories and their pollutants, right? So after this one, we should be able to explain strategies and techniques for controlling our SOx, NOxes, and other types of particulate matter, the PM10 and PM2.5. Anything below that? All right, describe innovation pollution control measures. All right, so we're going to talk about easy technology, we're going to talk about first world technology, and we're going to look to see how just simple little changes can make lives better, especially for women and young children. All right, so ways to address air pollution. The easiest way by far is to avoid emissions in the first place, right? That's the best way. It's 10 times more expensive usually to try to clean something up after it's out than before it's out, right? If you think about the analogy of a point source pollutant going into a stream, it's much easier to clean. Well, first of all, it's easier to clean if you just had some sort of regulation in place to prevent it from happening, but you definitely want to clean it at the source rather than making it everybody else's problem, right? Use a cleaner fuel, something that doesn't let out as many NOxes, right? Increase efficiency. Remember, these are old ideas right here. Increasing efficiency and control pollutants after combustion, right? So capturing them, right? So things like smokestacks and catalytic converters in cars. Okay, so ways of controlling emissions. Remove sulfur dioxide from coal by fluidized bed combustion. What that basically is you're getting gypsum. Let's see if I can write this. Gypsum. So you're using gypsum and limestone, and you are having that in the presence of the coal as it's being burned. And what you end up getting is, well, we just had to brown out in the entire school. What you end up getting is, what's it called? What am I trying to say? Holy crap. You basically get sheetrock. You get sheetrock out of it. So you're making a product that you would normally have to manufacture on its own, but you're doing it through the while producing energy through coal, right? Okay, catalytic converters in cars are going to suck up some of the emissions from the back. And baghouse filters, there's videos online of what baghouse filters are like. They're basically gigantic cloth pillars that go inside little air intakes from exhaust from coal factories. And they can be moist, they can be dry, and they will get a lot of the particulate matter in there from time to time cleaned up. Okay, electrostatic precipitators are just charging the smoke particles as they go up, and they get stuck to collectors, and they can be cleaned easily. All right, so this is how particulate matter can get picked up through a wet scrubber. All right, the entire school blacked out, so this is pretty awesome. So everything's turning back on. Okay, this air pollution device, particles are quote-unquote scrubbed from exhaust stream by water droplets. So they use water droplets to kind of weigh down the smoke particles as they come up. You can see here, right? So that it'll precipitate out the gravitational collection. It'll go into like a sludge removal system, which will eventually have to be cleaned, right? So there, it's not definitely like a completely clean fix, but you're reducing the amount of air particulate matter, right? And this will eventually have to go to like a landfill or be burned else. People are implementing innovative pollution control measures, right? We've tried a couple of these things. Reduce gasoline spilled at the pump. That's a really easy one, right? That's prevention. Restrict evaporation of dry cleaning fluids and use of lighter fluids, especially when you are doing things like barbecue, right? So not using some sort of lighter fluid precursor to burn your coal. Reduce the wood burning stoves and fireplaces because these things do release a lot of particulate matter. And limit automobiles to every other day or charge fees for roads turning. Okay, so my recording stopped. That was amazing, right? Something about the ghost in the machine is probably just my finger clumsily hitting the button. There are two different types of ozone, a good type, the stratospheric versus the tropospheric, and we're going to talk about those two. We're going to talk about how they interact with the three different types of UV radiation, right? So you have UVA, UVB, UVC, and they differ in their wavelengths, right? So you can kind of see I've drawn out these really awful wavelengths, right? So long wavelength, medium, and very short. This one right here, the one you need to know mostly, has the most harmful effects on human cells and in biological organisms because the wavelength matches very perfectly with a lot of our cells, so it interacts greatly. UVA doesn't hit the ozone as much because it's long. It doesn't interact with the O3 molecule chain, and it'll reach us, but it's not as dangerous, thankfully. So it'll cause things like sunburn and freckles and things like that. It can discomfort, but definitely not as much as the cancer-causing UVB. UVC is short enough to where it doesn't interact as much with us, right? All right, so we're going to look at depletion of stratospheric ozone and how to reduce ozone depletion. All right, so stratospheric ozone is roughly 45 to 60 kilometers above Earth. Ozone has the ability to absorb ultraviolet light. This is what we're talking about in the previous slide, and it protects life on Earth. So the depletion of that is obviously very bad, right? Ultraviolet spectrum is made up of 3 increasingly energetic ranges, A, B, and C. So A is over here. It's like an inverse relationship. The longer the wavelength, the greater the wavelength, the lower the energy, versus the short wavelengths over here, high energy. Because imagine if you're bobbing in a pool, if you had to make really, really quick, fast ripples, your arms would be burning very quickly versus making slow ripples. Now, assuming that, the waves have the same heights, right? All right, guys, you're going to want to know this equation here for how UVC and UVB interact with molecular oxygen, O2. So look here. You can see that in the presence of UV radiation, this guy here is going to break apart. It's the energy required. Its wavelength is small enough to interact with the molecular bond of O2, and it's going to break it up into elemental oxygen, okay, 2 of them. Now later on, so this is kind of like step 2 over here, it's going to come in and combine with another molecular oxygen and form O3, which is ozone, right? All right, now UVB and UVC are small enough to interact with O2. UVA, not so much, and it passes all the way down. So if we imagine this up here is the stratosphere, UVA is small enough to hit and interact and scatter all over the place, and it will not reach the ground. UVB also has a slightly larger wavelength, but not so short that it won't interact. It'll hit, break up, scatter across, and you'll end up with these guys over here, okay? But UVA won't do that, right? It's long enough to pass all the way down to the surface to get us, okay? And this is the thing that'll cause some sunburn, stuff like that. Now, if we have little holes in the ozone, these other forms of UV will be able to get us, right? And that's not good. Those are cancer causing radiation. All right, when chlorine is present, so now let's talk about how stratospheric ozone breaks down. Right now, remember, stratospheric is the good stuff, right? That's the good ozone that we want. It makes life on the surface of Earth possible, at least in its current condition, right? So when chlorine is present, and what does chlorine come from? It comes from things like refrigerators, right? The refrigerating components we used to use back in the day to cool things down are a set of compounds called chlorofluorocarbons, right? So those will attach to oxygen atoms when UV radiation hits CFC in the atmosphere, right? So what'll happen is it'll break up the chlorine we got here. It'll interact with O3 and break it down into O2 and a elemental oxygen somewhere else, right? Okay. Now this right here will break up again. Okay, it'll pull the oxygen and form it back into this again. And this chlorine atom is an ion. It's a very active ion, and it will not find another chlorine because this is a very low percentage in the atmosphere compared to all the other things, right? So we're talking about parts per billion, parts per million. It's going to be very, very low. So because there are not very many of these just laying around, it will not go and form with another chlorine and form a diatomic chlorine, which is very stable and not very active. So because it takes a long time to find itself a partner, a chlorine partner, it can do this up to 100,000 times statistically. So that's a really big number, right? You need to know that number. So up to 100,000 other reactions with ozone, right? So it's a catalyst in that reaction. Okay, so a single chlorine atom can catalyze the breakdown of as many as 100,000 ozone molecules until one chlorine atom finds another, and the process is stopped. So it's the exact same thing. So in this process, the ozone molecules are no longer available to absorb the UVB. So guess what? They come down to us. So you need to know that this is a multi-step process, right? And what type of harm are we talking about? We're talking about tumors and cancer and cataracts, okay? So make sure you know that. That's tumors, cancer, skin cancer, right, specifically, and cataracts. Okay, so make sure you know those. Okay, depletion of the ozone layer. So let's take a look at this graph here. So you see that ozone concentration It's gone down quite a bit, but it's starting to kind of go up. But you can kind of see it's kind of just a downward trend overall, right? So we've definitely come back from some of the events that were happening here, right? So remember, you need to be able to read graphs and decreasing trend, right, if you do a best fit curve. All right, indoor air pollution, let's talk about this. This is kind of interesting stuff, right? It's something that both industrialized countries and developing countries suffer from. It's something very, very interesting. So we're going to look at how indoor air pollution differs in developed and developing countries, describe the major indoor air pollutants and the risks associated with them. Worldwide, approximately 4 million deaths a year are attributed to indoor air pollution. 90% of these are in developing countries, so that's important, 90%, right? Okay, more than 50% are children, and when we look at why, so if we think about developing countries, what type of apparatus do they use to cook? They're going to use like wood burning, stoves, wood burn, and also biofuels. Other biofuels like, okay, this is a biofuel. Other biofuels like animal products like manure. Okay, manure, coal, right, which is not a biofuel, but maybe charcoal is, right? Charcoal is a biofuel. Okay, and these things create a lot of particulate matter. They let out a lot of sulfates. They let out a lot of even mercury for coal or charcoal, right? So because children stay at home with their parents a lot, they're at the greatest risk of getting indoor air pollution, and women as well, if women do stay home in some of these developing countries. All right, so let's look at some of the things that happen in the developed world. So anything that smells, like that new house smell, like that laminate floor, new cabinets, those smells, those are VOCs, and those can be very bad for you in closed, tight quarters, right? So furniture, carpet, foam insulation, so this stuff right here. I'm going to zoom in. Tobacco smoke, obviously. I grew up in a house of smokers, and I noticed that pretty much as soon as I moved out and went away to college, a lot of my respiratory problems went away, right? So that indoor pollution, even when people weren't smoking, just it always being on your clothes, the smoke particles getting on your clothes really make it tough. They do a number on your respiratory system. Back in the day, old paint used lead, so that's a major indoor pollutant that is a problem for us. And something to kind of think about as we look around here. Oh man, back in the day we used to use asbestos. Remember that cleaning up asbestos is very difficult because it scatters and shakes things up, right? It shakes up, scatters around the particles, right? And it can actually increase the concentration of asbestos more after you clean up asbestos than before. So you remember that video that they were showing, like how those companies go in and clean up asbestos. You have to have like airtight rooms and vacuums and things like that. You have to have highly trained professionals take care of your asbestos. What was I saying? But it's interesting that, you know, now that we have like these nice insulated houses and everything, to try to save money on energy, right? So this right here, this saves money. Saves that moolah, that green, right? A little guacamole. Right, it saves all that stuff. Saves us money by keeping it airtight and keeping the cost down for electricity, right? We're not having to use as much AC. But what ends up happening is that air doesn't get a chance to escape, right? It doesn't get to leave the house. We're just getting things at the very best case scenario, right? We're getting intake in, maybe from things like motor vehicles and pollen and microorganisms, right? So we're getting like a lot of bad stuff in and not a lot of stuff out, right? So because we're in this like nice little basically airtight compartment, we are exposed to a really high level of indoor pollutants, which is kind of weird, right? Something that we can regulate is the use and the amount of wood stoves, fireplaces, using things like precursors to lighting coal, like lighter fluid, right? Those things all kind of cause problems on the outside, but going back to the inside, these things cause problems for us too. Pesticides, paints, so anything that has a scent, if it's inside, it can be a pollutant for us. And now let's look at some of the things that are really, really dangerous. Carbon monoxide from your faulty furnaces. If you don't have this nice blue pilot light, if you have one of those gas heated furnaces, if you don't have a nice blue pilot light, that means you don't have complete combustion, which means you have a lot of leftover carbon monoxide if you have like a nice yellow flame. So you got to check that. Because it is odorless, it is colorless. It is one of the silent killers, just like radon and asbestos. Right? You're the silent killer. All right. Most indoor air pollutants differ from outdoor air pollutants. So indoor air pollutants include carbon monoxide from malfunctioning heating equipment. We just talked about that earlier, so check that pilot light, right? Remember that this right here binds to your hemoglobin. Better and more efficiently than oxygen, right? So because it does that, it's going to take over for the oxygen, and it's gonna take away your oxygen. You're not gonna be able to breathe, right? You're not gonna be able to carry out life functions. So that's why it's so dangerous, because if you're sleeping, you're not gonna know that you're, epoxic, Asbestos, okay, long, thin, fibrous silicate material with insulating properties. We used to use it as insulation. Can cause cancer when inhaled. There's asbestosis and lung cancer, and it was formerly used as insulation. Radon that seeps into homes through cracks in the foundation, groundwater, or rock. So if you live in the north, the Midwest, some parts of the Northeast and the Northwest, not so much in Texas, you need to really check your foundation for cracks, right? Check your foundation, because they can have gas seeps of radon gas, and this is from breakdown of things like uranium. Okay, and then VOCs from things that we talked about earlier, furniture, in your paint, building materials, lead back in the day, right? All those things can contribute to indoor air pollution. Woo, red dots. Okay, all right, so here's radon. Let's look at radon again. So again, these dark blue, let's read. You have to be able to read graphs. You can practically pass the AP exam if you can read, right? Okay, read a book. Okay, high, so the dark blue, so over here, this is where your risk of radon is going to be. Alaska too. So Alaska, that explains a lot, right? Hawaii, nice, real nice place to be, right? I think maybe California should break off and go ahead and chill with Hawaii. Maybe this part of Texas too, maybe just right where we are at. So we don't have so many problems if we have cracked foundations. It really is not too big of a concern, other than, having a cracked foundation, right, and having your house sink. That's not a good idea. But in terms of pollutants, that's not a source that we should necessarily be worried about. Okay, so let's talk about VOCs in home product and sick building syndrome. Sick building syndrome. You know what sick building syndrome is. Okay, so if you don't have good ventilation, aka you don't have a lot of your windows open, you don't have vents to vent things to the outside world, this is a really easy way to remediate and abate problems with indoor air pollution, just having windows open, right? So remember, that's one of those easy, stupid answers that you can put on the AP test. Okay, chemical contamination from indoor sources, those are your other VOCs and stuff like that. Chemical contamination from outdoor sources, so we said we have intake of air going in, and it could be like exhaust from cars and other things like that, or particulate matter. Biological contamination from outside or inside, we're talking about mold, black mold, white mold, all that stuff is bad for you. All right, and that about sums it up. I hope that was helpful. I feel like some slides are missing though. Yeah, okay. So there was a slide that I really wanted to talk about, so I went ahead and just added these pictures here. We're going to talk about them real quick. But sources of indoor pollution for developing countries have to do, like we said, cooking indoors, right? A lot of people just don't know because of okay, let's put it this way. Like, everybody you know dies at the age of 35, right? And that's just how it is. You're not going to know, you're not going to care that that part of the reason could be from things like cooking indoors, right, and just having really poor ventilation, right? And that if you were just to educate yourself, I mean, I'm not saying anything bad, but if you were just to have the education and the awareness that just opening up a window or designing your house so that there were ways for the particulate matter and sulfur to get out, or cooking outdoors, just things like that could extend your lifespan considerably. These are some ways that people have went about reducing indoor air pollution. Okay, so let's get rid of that. Nope. Okay, so these guys made this camping stove. They call it a BioLite, and what it does is it reduces a lot of the emissions here. Reduces a lot of the emissions. It uses solar power and things like that. Some of these use organic material. But what the important thing is that it cuts down a lot on the amount of coal you have to use. It really doesn't use all that much. All right, that's pretty neat, right? Now look over here. So that's kind of prohibitive because the cost is really high. Right, a lot of money on that. Some of those run like $200 or whatever. But this right here is something that most of y'all did if you were in GT classes in middle school. So check this guy out. So you did stuff like this where you had like some sort of reflective material. you focused it on like a focal point, and it created a lot of heat, and you're able to cook things like hot dogs. Just things like this, very simple, very elegant ideas that they not only are cost effective, they don't cost money to really set up, and they're clean, cheap, and they even reduce the amount of violence on women and children. Because if you think about something even like this right here, bring this guy back, you have to go and collect some sort of fuel source, right, like wood. And if you're in an area where you have to go out to the woods by yourself, depending on how dangerous it is, it might not be a very good idea. So this right here, you can cook right by your house. You can cook in a community square, and you don't have to worry about anything happening to you. So this is actually something that people have been using in a little place called Darfur. Right, if you look up Darfur, you can see that there are all these refugee camps and things like that. It was something that was going on when I was in college. It's very, very sad, but this is one of the things that not only helps the environment, it helps the human condition, and it also cuts down on energy, so it conserves. So I hope this was helpful, kind of tying in all these like global issues with indoor pollutants, air pollutants. Get ready for your quiz. Good luck.